So if you have the homework and or the study guide, a lot of times the study guide, if I literally kind of sit down with the notes and I write the study guide, and it pretty much follows the notes, and it's designed to really pull out what I feel is important. And one of the first questions right off the bat, and this one hops around a hair, but does the heart rely on a nervous impulse to generate a heartbeat? And what part of the nervous system impacts the cardiovascular? So does the nervous system, and this might be someone can either unmute themselves and say it, or you can type it in the chat, but I would like some interaction if possible. But does a nerve impulse need to generate a heartbeat, first and foremost? Oh, I gotta scroll down to my messages. Exactly. So, and then what portion of our nervous system is initiating or has an impact on the heart rate? If you dig back in your head and think about where does the, yes. Now I'm glad you put sympathetic. So sympathetic and parasympathetic are under the autonomic nervous system. So the best is going to be the autonomic nervous system is what impacts the heartbeat. And that's the automatic nervous system. If you remember, the two divisions were the somatic nervous system, which controls the body, which is things that are under conscious control. And then the autonomic system is the automatic functions, and then that is split into sympathetic and parasympathetic. Whenever you have a sympathetic response, so Teresa, you're absolutely right, it's your fight and flight. But then when you come out of that, then the parasympathetic kicks in. So usually there's a mirror. Any effect in the sympathetic system has a parasympathetic response. Heart speeds up, parasympathetic is going to slow down. When the force of contraction is increased, because that's making the heartbeat harder, so it can get blood everywhere it needs to go. When this parasympathetic kicks in, that's going to slow down, or that force of contraction is not going to be as strong. Now, again, what sets the heart rate for the heart? What is responsible for generating the basic heartbeat? Exactly. And where do you find the SA node? Okay, so it is in the right atrium. It is the SA node. Now, when the heart speeds up, the heart has, the heart does have some innervation. It does have nerve supply, but it's not to initiate the heartbeat, but it is to get feedback. So the nervous system is like, hey, I got to do this. And the heart goes, okay, I'll help you out. I'll beat faster. I'll beat harder. And that's how the inner nervous system and the cardiovascular system work together. So again, the best answer is the autonomic nervous system is what affects it. And that has sympathetic and parasympathetic function. Now, one of the questions on here, the next question, number 2, is what is the mediastinum and what structures are located within it? I'll be moving around this PowerPoint a little bit, but the mediastinum, if you think about the thoracic cavity, is like one big open cavity, okay? You've got the ribs and the intercostals are forming the lateral borders. The diaphragm forms the caudal border. And in that space, you've got all the thoracic structures. The heart is going to be more cranial, and it's in the middle. Media or median, mediastinum is the place that is where you find the heart, the majority of the blood vessels. There's some lymph nodes there, but it is in between the lungs. It's nestled, and we do the lungs next week. So it is in between the lungs, and that space is called the mediastinum. If you just tell me, think about it this way. When I ask essay questions, and I deal with this in all my classes. I'm dealing with this with anesthesia students. Sometimes I get this very short answer. And obviously, you're writing an answer to me, and you're assuming I know what you're talking about. But if you were to explain this to a family member, to a significant other, or if you were explaining it to someone that had no idea, they've never taken anatomy, how would you describe where it is? So sometimes people just say the heart is in the thorax. I'm like, the thorax has a lot of space. You would say it's located in the mediastinum between lungs. And the rib spaces, remember, are approximately ribs 4 to 7. So again, if a dog was standing about where the point of their elbow sits against their thorax, if you slide your stethoscope under there, that's about where you should find the heart. And the other thing to notice is, remember, we looked at those x-rays of dogs that should be pointing caudal. Okay, the heart does not sit straight up and down, and it does not point forward. It should be shifted caudally. Because remember, when you take an x-ray of a dog and you have an abnormal position of the heart, that is one indication of potential heart disease. That changes the axis. If it shifts the axis, which is the location, then we're going to be looking in certain directions. And it just says, so basically on that question is the mediastinum is in, and the heart is in between the lungs. The apex is shifted caudally. It actually has a little bit of a connection. The pericardium will actually connect here. And if you see this line, which is right here on the picture, that's the diaphragm. So it should be it'll always look on x-ray like it's touching the diaphragm through connective tissue, because the diaphragm will bow in, and it bows into the thorax. So the next questions 3, 4, and 5 are pertaining to the linings of the heart. Now, the pericardium, remember, is the sac that surrounds the heart. If we talk about the layers of the heart itself, technically the pericardium is around that. The pericardium isn't a layer of the heart itself. It's a sac that surrounds the heart. So the pericardium is very fibrous, and it should produce fluid. And fluid is considered serous. And anytime you see serous fluid, this word, it is pertaining to a watery consistency. When we talked about tissues way long ago, we talked about what structures and what linings produce what fluid. And serous pericardium, it should be a watery fluid. If we get into the other layers of the heart, okay, this is kind of like taking a wedge. Myo is muscle, so that's the muscle of the heart. The endocardium is on the inside, or is the layer within. The only one I didn't talk about, and it's right within here, is the epicardium. So the epicardium is the surface of the heart. The pericardium is on the other side, but you see there's a little gap here. Okay, now sometimes nobody asks me this question, but I sometimes get this question in class, because if you remember, I talked about pericardial effusion. An effusion is when there's an abnormal buildup of fluid in a space. Effusion just doesn't you have to tell me, where is the effusion? Pericardial effusion is effusion around the heart. But someone asked me once, well, what if you don't have enough fluid? We don't deal with that condition as much, but if for some reason it wasn't producing enough fluid, then that pericardium would stick to the heart, and it would become what's called an adhesion. Whenever you lack fluid in a cavity, you get adhesions where things stick together. Obviously, more often than not, I'd say 98% of the time, you're dealing with effusions and too much fluid. Very rarely have I seen a case where we don't have enough fluid. Okay, so most of the time, we're talking about these other types of conditions. So be familiar with the layers. And that number 6 asked, what is pericardial effusion? So I just explained abnormal buildup. Now remember, Until you look at the fluid, we don't know the reason for the effusion. The consistency of the effusion is going to tell us. The case I told you about the Shar-Pei, the fluid that was in there was blood because there was a tumor on the heart that was bleeding into that space. Sometimes you pull it out and it looks like serous or clear fluid, and it's buildup from heart disease. Sometimes it could be like pus-like, and it's an infection. So until you get the fluid out, we don't really know why there was an effusion. And that'll be true for pleural effusion, abdominal effusion, but the problem is you'll take an x-ray and you'll tell the owner, your dog has an effusion. And then they go, why? And then you're like, we got to look at the fluid. And then that'll probably tell us why there is an effusion. Okay. So effusion is just a piece of the puzzle. The 4 major chambers was the next question of the heart, number 7. And basically, right atrium, right ventricle, left atrium, left ventricle. The myocardium is just pertaining to the muscle. And remember, there is no communication laterally. Okay, there's no communication from the atria. There's no communication to the ventricles. The atrium sends blood to the ventricle, but it does not send from one atria to the other atria. Okay, it's got to follow that coordinated flow. And the dividing for number 8 and 9 is the septum. There is technically an interatrial septum and an interventricular septum, inter or between. It'll look like one structure in the heart, okay? And it is made up of connective tissue, and then the myocardium attached to that connective tissue. But it looks like it's a strip of muscle right here, but underneath that muscle is a layer of very dense connective tissue, and that's the structure of the chambers of the heart. The 2 arteries that leave the heart are going to be the aorta and the pulmonary artery. Okay, so the aorta and the pulmonary artery are the major arteries that leave the heart. Now, the aorta leaves from what side of the heart, the right or left? Yeah, so the aorta, it goes from the left ventricle out to the aorta, and then from the right ventricle, it goes out the pulmonary artery. Okay, which one of those arteries carries oxygenated blood? I'm skipping around a bit. Yes. Oh, look at all you guys. Yay. The aorta is oxygenated blood. And remember, I told you arteries always carry oxygenated blood, except the pulmonary artery. The pulmonary vessels are opposite, okay? It's called the pulmonary artery because it's leaving the heart, but it technically carries deoxygenated blood from the heart to the lungs. So, but every other artery in the body besides the pulmonary artery always will carry oxygenated blood. That's the rule. And hang on one second. Okay. Okay, so someone's trying to, okay. And then for number 11, which was what are the 2 veins that enter the heart? Remember, veins are always coming back to the heart. So the pulmonary veins are coming from the lungs back into the left atrium. And the vena cava, you have a cranial and a caudal vena cava, they're coming back into the right atrium from the body. Which one of those veins carries deoxygenated blood? Is it the pulmonary veins or is it the vena cava? Deoxygenated blood. Yes, it just came from the body. So every vein in the body, from your pinky toe that vein to your pinky toe joins with all these other vessels, comes eventually back to the vena cava, and it comes back to the heart. The pulmonary veins are carrying oxygen because they just came from the lungs. Now they're a vein because they're returning to the heart. But because they're from pulmonary circulation, they break the rule. The pulmonary veins are oxygenated, okay? So be familiar if I ask you a vessel, if I talk about where blood's coming from, I like to ask, is this blood oxygenated? Is this blood deoxygenated? And remember, if it's deoxygenated blood, it is high in something. It is low in oxygen. What is it high in? What does it have a lot of? If it doesn't have oxygen, it has something. Carbon dioxide. Okay, carbon dioxide is a byproduct of cellular metabolism. Now, the blood has a lot of other stuff in it, nutrients, wastes, but the primary thing I'm talking about for the first 2 weeks is oxygen and carbon dioxide exchange. So the blood coming back, the way the body gets rid of the majority of its carbon dioxide, it exhales it. So the blood goes to the lungs, and in the lungs, it diffuses oxygen for CO2. And that's where we balance. So let's see. For 12 and 13, if we're looking at pictures of the heart, 12 is the right side is deoxygenated and the left side is always oxygenated. So which side of the heart has what blood flow? Now for 14, where is the right AV valve located? It is between the right atrium and the right ventricle. It's called an AV valve, atrioventricular valve. The other name for that is the tricuspid. I prefer you to call it the tricuspid rather than the right AV valve. Some books and some pictures will call it the right AV valve, but in animals, we refer to their valves as mitral and tricuspid. Okay, so the right one is the tricuspid. The left one is the mitral. And I had put a little note on that image that I sent you, the one, I was proud of my coloring on this picture. I had fun that day. But on this side over here, I had put a little hint. I said L for left. So the mitral valve has an L in the name that tells you left. Okay. And then a quick question had asked about, oh, and remember, what is the job of the valves is to keep blood flow should be going in one direction in a figure-8 motion. When the atria contract, it pushes blood to the ventricles. When the heart goes into diastole or relaxation, that valve should snap shut. We don't want blood coming back from the ventricle backwards, okay? So the valves keep blood flowing in one direction, a unidirectional valve, and it opens and shuts, okay? Opens and shuts. Now, the chordae tendineae are sometimes called the heartstrings. They are found within the walls of the ventricle, and they will hold on to or anchor the heart valves. And like I said, if you think about a gate, if this was a gate in your yard, okay, and it goes like this, you may have like those little springs that attach to it. If you have like a screen door, it has a little spring and it, so you open it, it doesn't just go, like throw the door open. But that's what's happening with the valves. They've got these anchors, so when they go to open, they stop. Because of those chordae, they don't just go like this, okay? So they anchor the heart valves, and they are connective tissue. It's a tendon, they anchor to the muscles within the ventricles. Now, I have a question. I didn't get into this. I've not talked much what happens in the lungs yet, because that's what we're doing next week when we get into the lungs. But when it travels, when it says what happens when blood travels through the lungs with oxygen and CO2, when blood goes through the lungs, okay, CO2 is going to diffuse into the lungs, and oxygen is going to diffuse into the blood. I call it tradesies. I'm like, okay, let's trade spots. Remember, we are that little car. We are a red blood cell driving around through all these vessels. When you get to the lungs, the CO2 is going to get out into the lungs. The animal exhales. Blood or oxygen that it was in the lungs is going to come attached to our red blood cell, and then that red blood cell is going to come back to the left side of the heart and go back to the body. So within the lungs, CO2 should diffuse out into the lungs, and then oxygen should diffuse into the blood. Now we've reoxygenated the blood. And stop me if you have any questions or type any questions. I'm going to the back side, or there was 2 pages to this guide. The pulmonic valve and aortic valve. So for 18, where is the pulmonic valve located? The pulmonic valve, let me go back, is going to be right here. Pulmonary valve sometimes goes by the pulmonic valve, same thing. It is located at the level of the right ventricle as it exits to the pulmonary artery. That valve is a one-way valve. So when the ventricle contracts, that valve has to open, okay? When the heart is in diastole, when the ventricle reacts, that valve is going to shut, because we don't want blood going backwards from the pulmonary artery back into the ventricle. So the question below it says, when is the pulmonic valve open / closed? It is open during ventricular systole. It has to open to let the blood out when the ventricle contracts. When is it closed? It's going to be closed during ventricular diastole. Okay, so when the ventricle relaxes, it's going to shut so that blood doesn't come backwards. Okay, same question. Hang on, let me go down. Oh, never mind. And for 20, I had which vessel, sorry, I'm gonna get my glasses out for this one. I had which vessel delivers blood from the lungs back to the heart. We talked about that. That's the pulmonary vein. The aortic valve is located between the left ventricle and the aorta. Okay, so here's the left ventricle. It's hard to see because it's literally behind here. Okay, it's back here, and it is going to be open during ventricular systole, and it's going to be closed during ventricular diastole. Same thing. When the ventricle fills diastole, it's going to prevent that from going backwards. Okay. Oh, the other thing, I think it's the next picture. Remember the coronary arteries, 23, where are they located? Where are they found? What are they? Where are they found? Okay, they are found on the outside of the heart. The coronary arteries are a branch, literally, think about, okay, if blood comes out of the aorta up here, a tiny little branch, it's kind of like a little exit ramp off the side, is going to wrap around and feed the heart. And they supply the heart with oxygenated blood. That's the job of the coronary arteries. I didn't bring this up in lecture. In people, if people have a heart attack and there's a major heart attack and they call it the widowmaker. My neighbor 2 houses down was shoveling on a winter day. Luckily, we have a hospital very, very close to where we live, and he got in right away. But he had a major blockage to his coronary artery. If someone says, I'm having a coronary, this is where this comes from. If there was a blockage here, how is the heart muscle going to get oxygenated blood? It does not absorb blood from inside, okay? So when people have blockages to their coronary arteries, this is how people have heart attacks. What happens is the myocardium, this muscle, is deprived of oxygenated blood. Muscle cells die. When muscle cells in the heart die, they cannot send those electrical impulses, right? Because the electrical impulses are embedded in the muscle of the heart. If you have muscle of the heart that isn't getting oxygen, it can't function. And this is where heart attacks come from. So the coronary artery blood flow is very, very important. We do not deal with cholesterol issues in dogs like we do in people. Now, sometimes there is cholesterol on a blood test that animals get, but I can't tell you, I feel like we almost never look at that value. In people, it's huge to monitor your cholesterol. It's very important for good blood flow. But that's the issue, is you have blockage of the coronary artery, the heart muscle does not get oxygen and it does not function, okay? And the heart muscle, remember, is going to perfuse. When I say perfuse, that means oxygenated blood is getting into those tissues. It happens during diastole. Remember the kitchen sponge. If I got a sponge full of water, when I squeeze it, the water comes out. When I relax the sponge, I can fill it with water. Same as the muscle. When the muscle is squeezing, it's not going to get as much perfusion as when it's in relaxation. So my big take-home message is we need good blood flow. Second of all, an animal, the bigger the heart, the slower the heart rate, it gives the heart time to be in diastole and fill, and it gives the heart time to be in diastole to perfuse. That's very, very important. For 24, arteries carry oxygenated blood away from the heart. Artery away, AA, artery away. And then the exception to this is 25 is the pulmonary artery. And then 26, veins carry deoxygenated blood towards the heart. The exception is the pulmonary vein. So I think we've covered that, unless you have a question, or you can bop in with a question. For 28, when blood flows through capillaries within tissues, what is lost and what is picked up from the blood? Okay, so when blood, remember, a capillary is our smallest blood flow, okay? When the renal artery goes to the kidney, it is not giving oxygen. Oxygen cannot diffuse out until it gets to a capillary level. When it hits the capillary, oxygen is lost or given to the tissues, and then CO2 is picked up, and then that capillary goes back into a renal venule and a renal vein. When I have labeled the blood flow for you, okay, I wrote that out, every part, you have to wait till you get to where it says capillary. Capillaries are 1 cell thick, and when you look at pictures, okay, this is exactly what I'm talking about. This thing that looks like a net, those are the capillaries. I picked the kidney down here, okay? It goes aorta, renal artery. These smaller ones are renal arterioles. And then inside here, you get to the renal capillaries. Oxygen is given to the kidney. The kidney gives the capillaries CO2. Then they go to renal venules right here. This is the renal vein. The renal vein enters the vena cava, which is going back into the right atrium. And remember, blood flow goes from big to little, capillary, then little to big. Just like you going home from 465, getting off on a bigger road, then a medium road, then a small road, then you pull into your driveway. It's a small branch. When you go back, you're going to go from your driveway to the smaller road, to the medium road, to the big road, and you get on 465. So it's the same theory as getting off of roads. Obviously, your driveway is a very small part, and then you go back and you repeat it, but you go from your driveway to the bigger. And hopefully that analogy makes sense. It should. What is blood pressure? So when we talked about blood pressure, it's the amount of pressure exerted on the arterial walls. And a cardiac cycle, let me go back for a second, or let me, okay. So that's the blood exerted on the arterial walls during systole. And so what we're measuring is we're measuring the pressure in all the systemic arteries. Blood pressure is a representation of what is happening in the whole body, primarily from the left side of the heart. Okay, we're not concerned with the pressure necessarily because it's just going to the lungs from the right side. Blood pressure is really a division of systolic pressure, diastolic pressure, and mean. Systolic is always going to be your highest number because that's the pressure during contraction. Remember, diastole, your lower number should not be as high as this number because that's the pressure in your heart arteries when the heart is relaxing. Okay, if the heart is not pumping, there shouldn't be excessive pressure there. And then the mean is the average. And remember, I said for a mean, 60 is the normal number. 60 is the minimum mean pressure that it takes to get blood flow to all of the organs. Okay. When it starts going below 60, the body starts to shift blood from like the kidneys and the intestines, and it's going to defer that blood to like heart, brain, lungs. The body is starting to go in survival mode. So it has to prioritize. It can't get blood everywhere. And the big thing is 31 is why is blood flow important, or blood pressure? I just explained. You have to have enough blood pressure to get oxygenated blood to all of your tissues, which means perfusion. Perfusion is the body's ability to get oxygenated blood to all of the tissues. And then a pulse you feel in a superficial artery, and it is the recoiling of the arterial fibers during contraction and relaxation. Okay. The period where the heart is relaxing and filling with blood is diastole. The period when it's contracting is systole. EKG stands for electrocardiogram, and it is a graphic representation of electrical activity. It's a graph. Gram is a picture. Anytime you see graph or gram. Now, what it is representing, let me go back. Is this. This is coordinated electrical flow. This is the conduction system of the heart. Now remember, this is electrical activity. You need to know the difference between electrical and mechanical activity. Mechanical activity is when the heart physically contracts and pumps blood out. That is like a mechanical pump. The electrical activity is the impulse to initiate the pump. Now think about this, okay? Say you have a water pump and you plug it in the wall, okay? And you hear like popping, but yet the water doesn't pump out, the pump doesn't pump out any water. Just because you hear electrical zapping doesn't mean the pump is actually functioning. Now, if the electrical system is working, it should initiate a coordinated contraction of the heart. And then that's how you get coordinated blood flow, if this is working properly. But remember, I said occasionally you get that thing called EMD, electromechanical dissociation, also sometimes known as pulseless electrical activity, where the electrical system fires, but the heart does not beat. If your heart is not beating, you are dead. If your dog's heart is not beating, it is dead. I don't care what the ECG looks like. If you cannot hear a heartbeat, there is no blood going anywhere. That is called death. I'm sorry, I'm being frank and blunt. You have to always back up an ECG by listening to a heart beating. So I would never monitor an anesthetized animal just by looking at the EKG. and assuming that my patient is alive. You have to at least feel a pulse somewhere, and you have to at least hear a heartbeat. Let me type it for you, Sean. EMD, electromechanical disassociation. I think I spelled disassociation correct. I might be a little spelling challenge this morning. Okay, so now that does not happen a lot, but the take-home message is you need to know this blood flow. I'm sorry, this electrical flow. So question 37 is, what is the purpose of the SA node? That is the pacemaker. What are the Purkinje fibers and where are they located? The Purkinje fibers are an extension of the electrical system, and they are located in the ventricles of the heart. What is the AV node? The AV node is the connection from the SA node to the Purkinje fibers. Think of like an electrical impulse has to go through like switches. Okay, so it starts in the SA node. The AV node is going to pause or delay that impulse and then going to send it to the Purkinje fibers. So we have a coordinated, if the SA node just fired, the whole heart would just contract at one time. So the SA node, this AV node is kind of like, wait, okay now. So the SA node fires, the atria contract, the AV node will send a signal to the bundle of His or Purkinje fibers, then the ventricles will contract. But the AV node is to kind of slow that impulse so that everything flows in the proper direction. So the proper flow should be SA node, that splits to the atria. It's going to transition to the AV node, which will pause the signal. And then after the AV node, it'll go to the right and left branches, which go to the Purkinje fibers, and then it goes. So then the atria contract, then the ventricles contract. So you do need to know the order of the proper impulse through the heart. And then my last question on here is the, oops, hang on. That's not what I want to do. Okay, that's what I wanted to do. No. Can you guys see this picture? I lost my chat screen. Where's my chat screen? Okay, so maybe, hopefully, normally, like I said, normally in class, I give you this blank and I have you fill this out yourself. Just for added benefit, I went ahead and filled it out how I would want you to fill it out. And then I sent you a blank. So hopefully you had my colored version and you had a blank one that you could potentially fill out. And a lot of people draw this themselves. If you're artistic, you can practice. Yes, Shauna is correct. The other thing is the right and left bundle branches. The right and left bundle branches are also known as the bundle of His. So it's going to go SA node, AV node, bundle of His, Purkinje fibers. Okay. Now on this picture, we talked, and then I gave you the handout that I sent you. This proper blood flow. That's literally how it will be. You have to put it in the right order. You have to type it in the right order. First time, I give you a word bank. Then we take away the word bank. But I want you to be able to put it in the right order. If we look at the flow, and I always start with the aorta, is the aorta is going to go to the body. Okay, so it's going to go aorta. And for my example on your paper, I had put renal artery, but I want you to pick a different artery. I don't want you to use renal as an example. So I have renal artery, renal arterial, capillary, oxygen for CO2, renal venule, renal vein, vena cava. Vena cava is right here. Now the caudal vena cava is coming from the back half of the body. The cranial vena cava here is coming from the front half of the body. So they join into the right atrium. They go through the tricuspid valve to the right ventricle, out the pulmonary valve to the pulmonary artery to the lungs. At that point, you just, after the lungs, you just write CO2 for O2. Then you trade. You give CO2, you pick up O2. Then it's going to come here. This is what I forgot to label on here, is the pulmonary vein. Pulmonary veins are going to empty into the left atrium, go through the mitral valve, left ventricle, out the aortic valve to the aorta. Wherever you start, you end. Okay? So wherever you start, you end. In this picture, and then you have the myocardium here. Okay, so that's the muscle of the heart. And anywhere you have DO2 means deoxygenated. Anywhere you see O2 means oxygenated, and CO2 equals carbon dioxide. So I want you to be familiar with those abbreviations. Now, again, if you see this picture, I could point at anything and say, where is this going? Okay. I might say, what does this chamber have, oxygen or deoxygenated blood? What is this? This is the septum. There is muscle there, but the job of this is to separate the ventricles. Now, the other thing that wasn't on the study guide, a couple of things that we went over to review, is cardiac output is heart rate times stroke volume. So you needed to know that formula. That is the amount of blood being put out from the left ventricle during systole. How much blood is available to go to the body. The other thing was the foramen ovale, and whoops. You remember this picture, which was in fetal circulation, in utero, they have an opening here, which is the foramen ovale, and then they have a ductus arteriosus. When they take their first breath, the foramen should close, and the ductus should ligate, which means close. That will force blood to the lungs. So which one of those things did I say could be repaired surgically? Oops, where's my chat? Anybody remember? Yes, the ductus, the PDA. So if a dog has a ductus, or what we call patent ductus arteriosus, it means that the ductus remained open. We can go in and surgically tie that, and then that would force the blood to the lungs. So do I see this disorder in a 10-year-old dog? You do not. A dog is not going to live past maybe 4 or 6 months old if they have a PDA. They can live for a while, for a little bit, but they're going to eventually be such a poor doer. I mean, they would be very, very sick. So this is something that's diagnosed in, young puppies. Okay, is there any questions? Because I know you got to get ready to go. Don't be late to your ClinMed or whatever you got to go to. Does anybody have any questions? I will obviously, thank you. So if we measure cardiac output, that's heart rate times stroke volume. Now, to get stroke volume, you need to give a cardiac ultrasound. You can get a heart rate, but to get the stroke volume, you would need an ultrasound to measure how much is coming out of the left side of the heart during systole. So once you get that value, you would multiply that by heart rate, and that would give you the dog's cardiac output. But remember, there's preload. Preload is what blood is coming into the heart. And then there's afterload, which is the resistance to the artery. So when the heart pumps out the ventricle, it can only pump as much blood as it got into the heart, and it can only pump out to a certain diameter of a vessel. So if we have a crappy cardiac output, if we don't like our value, then we have to figure out, well, why is it crappy? Is it the heart is diseased? Is it we have decreased preload, which is usually dehydration or fluid loss, blood loss? Is it an alteration of our vessels leaving the heart? So there are still pieces, but for the moment, I just want you're not going to have to calculate this. I just want you to know that equation. Okay, I will obviously, as soon as I get done, this will be recorded. I will send it to you with the parameters for the test, how long the test will be open. And I will try to figure out how to send you the homework key. I still have to enter the homework points. And I know people sent it in email and Teacheries. I will get it all sorted out. No worries there. But I will email you with the video from today. And if you have questions studying tonight, hopefully before 10 o'clock. After 10 o'clock, I can't guarantee you I'm going to email you back. Email me. All right, I'll let you guys get to, I'm unmuting everybody, but you're free to go unless you have another question. But I don't want you to be late.
Thank you.
Thank you. Good studying. I think you guys got this. It'll be great.
I think it's much easier to understand than nervous and tissue.
You're what?
Said I think it's much easier to understand than nervous and tissue.
Yeah, I hate the tissue section. I hate the skin section. So cardio, usually people do pretty good on. Usually it's a pretty good test. So it makes a lot of sense. It's something tangible. So I'm crossing my fingers. It's going to be fantastic.
Have a good day.
You too. You guys take care.